Statistical sampling. This is very important when you are doing an inspection. It is very important when you are doing control quality. It is very important when you are doing delivery, validation of scope. These are choosing a part of a population of interest for inspection. The sample is taken to measure, control, and verify the quality. When you have a batch of 1,000 pills or a batch of 1,000 shares, a batch of 1,500 cards, you will definitely have a quality check for all of it independently, but you would have some sampling to see that how the process is. When you are running the reports and the process purchase order daily, you cannot go for all 5,000 purchase order in terms of sampling. What you would be doing is taking the, in terms of the population, what you would be doing, you would be taking some sampling out of it, and then based on this sampling you will see whether the person or the people or the group of people or the team, are they following it, are they following the results, following the identified process or not, is the deliverable is as the quality that we have agreed for. So sampling is the selection of subset of individual from within the statistical population to estimate characteristics of the whole population. So I would say that if this batch is for 1,000 and I have selected 100 and 90% have passed, 5% are okay and 5% are bad, so I would say as part of the whole batch almost 50 will be failed in terms of their final quality deliverable. Determine the variables to measure. From the beginning, we have to move away from qualitative terminology. We have to move away from my word against your word. We have to move away from that what is my understanding of good and what is your understanding of good. We need to put figures, a clear measurable figures. So determine the variable and to measure, determine the population, describe the method of sampling, select the size, collect and get the data from the sample. It is largely used for quality. The problem is, what is good coverage? I have seen data in the last election where the data is for 10,000 for 1,500 for a constituency where you have 400,000 people. No, you cannot have it. Then I see a data that it is for a specific area, a specific kind of a people. I mean, this area, when you are doing a constituency sampling, this area is not happy with you. So it is very interesting when this sampling comes and plays a very interesting role in our lives, specifically when we see it. And thus, if you find multiple TV anchor, they are standing in the same area, in the same constituency, and the results are completely different. The problem is their coverage. The sample that they are selecting is not good enough. It is biased towards anything. So they have gone into an area which is not very happy. They have gone into an area which is ethnically different. The results will be different. So your sampling has to be very good. It's a challenge to have a good sample in terms of expecting, because you are, whatever the results you will get from that sample, you will assume it for the whole group. So if your sampling does not have enough coverage or a good coverage, your results will be biased, or at least you will have a wrong results in terms of the final data representation. Well, now it is time to go into a little bit deeper in terms of sampling. The idea is very simple, that I want to give you the overview of how you will be selecting a sample, or if any one of your teams who is looking after the quality control within your team and he is part of an inspection team of your delivery or quality control, how should they be doing it? And if they are giving you any specific terminology, at least you would have a fair idea. So we have two kinds of a sampling. One is probability sampling, another is non-probability. In terms of probability sampling, we usually have systematic samplings, random sampling, stratified sampling. And non-probability sampling is convenience, quota system, and all these are non-probability sampling. The idea behind this sampling is to obviously ascertain the fact whatever be the results we will get from the sample, we will assume for all over the population. So first of all, we have a systematic sampling. Starting randomly and select the next item systematically. So you have a population of 1,000. So every 50th you will select. This will give you pretty unbiased and responsive, representative, I would say, sampling, because these are the two important factors when you are talking about the sampling. It should be unbiased and it should be representative. The next one is random. Random select the next respondent from the population to maximize the representation and being unbiased. So you will be selecting any without any biasness or pre-assumptions or any questionnaires or anything. This is like a lottery. You will get a very uh, fair number of representation. Then we have a stratified sampling, or the advanced version is cluster. So divide the population in subpopulation, also known as strata, and then select from each randomly. So we have selected all males, all females, or 825 or 230, stuff like that, and then we select randomly from them. It will also give you pretty representative and unbiased data. Then purposive. Uh, I would not say that this is again a non-probability sampling, but it would definitely fall into that. Reason being, you have identified the predefined criteria, and then individuals are matched over that what will be the so anybody who is aged 25 and above, masters, living in this area. So these are a purposive sampling. Then we have a convenience sampling. You would not go, you are not actually trying to do an effort, you whatever are close by you, you are collecting this information. In this kind of a sampling, we have a self-selection bias usually come in, because if I find that the questionnaire or the sampling topic is chocolate, I would like to jump in. If I find the sampling topic is anything which is controversial, I might say no. So this is self-selection bias comes in. So these are the different kinds of way how you will actually gather the sample over the population. Then while you are getting the answers, you have two kind of the responses. One is attribute and discrete sampling, where the answer is yes or no, true or false, pass or fail. You will actually fail, or you will say that this product passed the test or this product failed the test. The next one is variable and continuous sampling. I'm sure we all have seen multiple times: bad, good, very good, satisfied, very satisfied, starting from unsatisfied, very satisfied, very unsatisfied, satisfied, very satisfied. So it's a scale of 1 to 5 or scale of 1 to 10, and you try to grade yourself or the sample that how good it is. So it is in term, this is what usually say when you have a space that anything above 80% is okay. So you say yes, it is for fulfilling the 80% of this. You usually do these kind of a continuous sampling when there is a grading is happening. When you do like classroom test, A, B, C, D. So some is passed at B, some is passed at C, some is passed at D. So in the pass section, then you usually get this in training schedule. Then you usually get this in terms of courses. So here the idea is that you are actually quantifying the degree of conformity based on the continuous scale over the period of time. So this is about sampling. As I said, we have a population, we cannot go back to the population. Population is very big, but we have to have a sample. We want to make sure that our quality is up to the mark. We want to make sure that whatever inspection we are doing, it has a proper unbiased and representative sampling. So there are multiple ways of doing it. I have explained you 5 and 6 of it, and then this is the how you will gain the result. This is where I close my topic for today. for sampling. We started from the sampling, how you will do the sampling, and these are some of the kind of the sampling. Definitely this is absolutely not equivalent to some sampling course that you would do in statistics course. There you will be having a detailed conversation of all this and why you should be using systematic sampling, why should you will be using random stratified. So there are purposes for these things. You have to use systematic, you have to use random sampling. Like I can give you one quick example. Systematic is easy when you are actually doing fruits and vegetables, and when you are doing actually the manufacturing. Random sampling is good when you are doing population and you are in part of any school, college, you want to have some question answers. Stratified is it's a time taking. You need to first of all understand your population, then you need to make stratas out of it. So there are specific reasons, question answers, types of sampling that you would be looking at when you are actually doing as part of your statistics. So here, as I said, project manager is a breadth of knowledge rather a depth of knowledge. You should have a fair idea about everything that is happening on your project. You would have subject matter experts on your project that would be doing a quality control, sampling and inspection and everything. What you need to know, you need to understand the terminology, you need to understand what they are doing. And this is where I believe this topic, whatever I have covered in this topic, is more than enough for you to be a better judge, to have a better judgment when somebody comes up with the sampling sample data and sampling results. Thank you for today, and we'll see you in the next session.